In the event that Earth is wiped out, boundaries, the most captivating celestial body I recognize is the one that might be extraordinary in our sky. It is this one, Betelgeuse. It's a massive red supergiant star. And if you were to position it where our Sun is, it would extend all the way out to the orbit of Jupiter. This massive, extremely unstable star is on the verge of exploding. It is not as simple as it may seem. In the cosmos, these colossal events, like the most extreme supernovae, could shake everything we observe and even things we don't. Though we cannot see it clearly, Betelgeuse is considered a representation of a red supergiant star, typically much larger than our own Sun. Brian Cox, along with other astronomers, believes it might explode in a supernova soon. People have grown increasingly concerned about what's going to happen because the James Webb Space Telescope has been capturing remarkable images of the star. When exactly will Betelgeuse erupt into a supernova, and how significant will the impact be on Earth? Let's delve into a star in the splendid Orion constellation that shines so brightly that even ancient civilizations noticed it. The splendid star Betelgeuse resides on the eastern shoulder of the Orion constellation, ranking as the second largest star in Orion. Its name derives from this, indicating that it is a shoulder star. Betelgeuse is likely one of the brightest stars visible in the night sky. In addition to its brilliance, the star emits an unusual red hue, which, as we will explore, signals potential danger. Humanity has long studied Betelgeuse. Greek astronomer Ptolemy observed it long ago. At that time, the first thing people recognized about stars was their color. Ptolemy noted that the star seemed to have a reddish-orange hue, an alarming indication. In recent years, scientists have been paying attention to the star with even more precision, and they now have a much clearer understanding of what makes it so strikingly luminous. One of these factors is that the star undergoes significant differences in brightness, fluctuating by as much as 0.6. Betelgeuse is a variable star, meaning its brightness changes periodically. In 2019, researchers observed some brand new behaviors of the star that had never been seen before. Even though Betelgeuse didn't stop shining entirely, its brightness significantly decreased. It dimmed to a level of around 1.6, prompting experts to investigate why such an irregularity was occurring in one of the sky's brightest stars. They hoped to discover an explanation for why Betelgeuse was acting so erratically. According to their findings, Betelgeuse could explode as a supernova at any given moment. Brian Cox, a renowned scientist, shared this alarming assessment. As a distinguished professor of particle physics at the University of Manchester and the Royal Society Professor for Public Engagement with Science, his opinion carries weight. He also presents popular science TV shows and writes books, making his perspective well respected. Brian Cox explained that Betelgeuse seems like a ticking time bomb, one that could erupt with little warning. To support this claim, the James Webb Space Telescope has provided substantial evidence. Although several peculiarities about Betelgeuse have raised many questions, why does Betelgeuse act so strangely in terms of its variability? With the new data, Betelgeuse has earned its place as a candidate for a supernova. However, researchers still don't know when the explosion will take place. The mass of Betelgeuse, nearly double that of the Sun, supports this classification. Generally, stars with at least several times the Sun's mass are considered to be candidates for supernovae. The plot thickens, though, because scientists have used different tools to investigate Betelgeuse, such as the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory, to uncover mysteries surrounding the star. What they've uncovered is still shrouded in mystery. Betelgeuse was born on August 31st, a very long time ago, and since then, the star has been offering strange signals that keep its future uncertain. What did they discover? They detected peculiar light waves emanating from the star, which raised further intrigue. But this wasn't the only bizarre incident. That brings us back to the fact that Betelgeuse is a variable star, fluctuating in brightness. There were reports that Betelgeuse had regular darkening episodes, akin to sunspots on our own Sun, but the cycles were different. It shifts between bright and dim phases twice as rapidly as it once did, another odd sign that Betelgeuse is misbehaving. Researchers observed that in February 2021, the star's dimming cycle reached a brightness band of plus 1.61. This was not long after the star had experienced a massive dimming event, marking the beginning of its abnormal behavior and raising alarms that Betelgeuse might be nearing the end. The significant dimming between 2019 and 2020, reaching its lowest level, made many experts convinced that the star would explode within the next 100,000 years. But when Betelgeuse brightened once more after this unprecedented dimming, things became even more bewildering. As physicist Andrea Dupree from the Harvard-Smithsonian Center for Astrophysics noted, the star was now 150% brighter than usual, making it the seventh brightest star in the sky. Researchers were astonished to see a red glow emerging from the southern part of the sky. The situation only became more puzzling. This development sparked numerous theories about the cause of Betelgeuse's great dimming. It's essential to highlight that not every star radiates the same red glow that Betelgeuse does. This glow marks Betelgeuse as a red supergiant star, which is the star's final stage of life before its death. This red hue is the result of a surface temperature around 3,500 Kelvin, significantly cooler than the outer layer of the Sun, which is around 5,500 Kelvin. Since Betelgeuse is cooler than the Sun, it radiates less energy per unit of surface area, even though it is much larger and on the brink of exploding. We should also consider the extraordinary dimming event that Brian Cox questions. Does it really mean Betelgeuse will go supernova? The fact that Betelgeuse is already in its red supergiant phase indicates that it is getting close to the end of its stellar power. A star in this phase will often dim as it dies, and this is something scientists can detect. However, Betelgeuse's recent unusual behavior has caused scientists to be even more focused on monitoring it. Today, multiple telescopes are focused on this mysterious dimming event, trying to gather more insights. Things continue to get even more intriguing, since researchers still don't have a deep understanding of Betelgeuse's behavior. Using cutting-edge instruments, scientists are watching the star closely. The James Webb Space Telescope is one of the most valuable tools since its launch in 2021, helping astronomers gather new, valuable data about Betelgeuse. The telescope's images of the star's remarkable dimming have shown that the event caused an enormous mass ejection, roughly 400 billion times more significant than a typical coronal mass ejection. The James Webb Space Telescope can also observe things that are invisible to the human eye, such as specific wavelengths of light and frequencies, making it an invaluable asset. Researchers have observed dust clouds forming on the star's surface that appear to resemble leaves in space, an odd but fascinating finding. As scientists peer deeper into the cosmos, Betelgeuse serves not only as a subject of fascination but also as a powerful symbol of stellar mortality. Its impending fate reminds us that even the mightiest stars have lifespans, and their final moments are as breathtaking as their prime. But why do we care so much about a star so far away? Because when Betelgeuse goes supernova, it will offer an unparalleled natural laboratory. The explosion will allow astrophysicists to study, in real time, the dynamics of stellar death, shockwaves, neutrino emissions, nucleosynthesis of heavy elements, and the formation of neutron stars or black holes. These insights could reshape our understanding of star formation, galactic evolution, and even the origins of life. There is also an emotional, almost poetic dimension to the anticipation. Generations of humans have looked up at Orion's shoulder and seen Betelgeuse burning red in the winter sky. It has been a fixture in our mythology, our navigation, and now our science. The idea that it might vanish, replaced by a brilliant flash and, eventually, emptiness, is both awe-inspiring and sobering. Will we be the generation to witness it? That question lingers in observatories and classrooms alike. School children learn about Betelgeuse with wonder in their eyes. Astronomers check brightness data daily, comparing charts and spectra. Some even sleep with their phones on, ready to be alerted by an automated telescope network in case the supernova finally begins. And when it does happen, Earth won't be in danger, but the night sky will change, profoundly and permanently. For weeks, even months, the sky will host a second moon, a brilliant beacon that will outshine everything else, casting shadows and turning night into a surreal twilight. We'll see headlines. We'll see photographs. But more than anything, we'll feel something elemental, a connection between our small, fragile planet and the vast machinery of the cosmos. It will be a moment of unity, curiosity, and reflection. What happens after Betelgeuse explodes? Following the spectacular explosion, Betelgeuse will enter the final phase of its life cycle. Depending on the precise mass of its core, it could become a neutron star, a superdense remnant packed into a sphere just a few kilometers wide. Or, if the core is massive enough, it might collapse into a black hole, warping space and time around it. Either way, Betelgeuse's material will scatter across the interstellar medium. The elements forged in its core, carbon, oxygen, iron, will drift through space, eventually becoming part of gas clouds that may, in time, form new stars, planets, or even life. In a way, Betelgeuse's death will plant seeds for future generations of cosmic creation. This is the ultimate cycle of stellar rebirth. As we await the moment, we are reminded of how far our technology and understanding have come. 1,000 years ago, a supernova might have been interpreted as an omen. Today, it's a scientific marvel. We may not be able to predict the exact date, but we are ready to capture, study, and learn from the cosmic drama when it unfolds. Until then, Betelgeuse remains a mystery wrapped in crimson light, its fate written in the language of the stars, waiting to be read. And perhaps, as we gaze at its shimmering red glow tonight, we'll pause not in fear, but in awe, knowing that we are witnesses to one of the greatest stories the universe has to tell. I have investigated and observed numerous stars, but none have received as much attention as Betelgeuse. Its immense size, variable brightness, and unusual color have made it a subject of intense research. As a red supergiant, Betelgeuse is already in the final phase of its life cycle. The star's massive size means that it will eventually exhaust its nuclear fuel, resulting in its ultimate demise and subsequent explosion into a supernova. This explosive event will release an astonishing amount of energy, significantly altering the surrounding cosmic environment. Despite the many concerns regarding the precise timing of Betelgeuse's supernova, astronomers are in agreement about one thing: the star will eventually die. It is one of the most significant cosmic events to occur in our lifetime. The data being collected by the most advanced telescopes today is helping to unravel the mysteries of the star, providing crucial information about the processes that occur during the final stages of a star's life. By studying the behavior of Betelgeuse, scientists can gain deeper insights into the broader mechanics of stellar evolution. Moreover, the explosion of Betelgeuse will likely leave behind a lasting impact on the surrounding space, enriching the interstellar medium with heavy elements that will eventually be incorporated into new stars, planets, and potentially even life forms. This cycle of creation and destruction is a fundamental aspect of the life cycle of stars, and Betelgeuse's supernova will be a prime example of this cosmic process. As we continue to monitor Betelgeuse and other stars in similar stages of evolution, astronomers are using cutting-edge technology to better comprehend the factors at play. The James Webb Space Telescope, complete with its unparalleled ability to observe distant objects in the universe, is providing a wealth of data that will shape our understanding of stellar dynamics. The images and measurements captured by this telescope are helping to shed light on the complex mechanisms that drive a star's evolution, from its birth to its ultimate demise. Although the death of a star may seem like a cataclysmic event, it is in fact a crucial step in the ongoing cycle of stellar evolution. The elements released during a supernova aid in the formation of new stars, planets, and perhaps even life. In this sense, the death of Betelgeuse and stars like it is not an end, but rather a transformation that fuels the birth of new celestial objects. As a result, Betelgeuse's supernova will play a significant role in the ongoing evolution of the universe, contributing to the creation of the building blocks for future generations of stars and planets. Until the day Betelgeuse finally explodes, astronomers will continue to observe and study its behavior, piecing together the clues that will help them predict its future. The star's unpredictable dimming and brightening cycles, as well as its other unusual behaviors, make it a fascinating subject of study. With every new discovery, scientists are learning more about the processes that govern the life cycle of stars and, by extension, the evolution of the universe itself. The mystery surrounding Betelgeuse's fate serves as a reminder of the vastness and complexity of the cosmos. The universe is brimming with unimaginable wonders, and the study of stars like Betelgeuse allows us to glimpse the incredible processes that shape the fabric of reality. As we continue to explore the cosmos and deepen our understanding of the forces that govern it, we are reminded of the fragile, transient nature of life itself. The stars, including Betelgeuse, shine brightly in the night sky, offering a glimpse into the extraordinary and ever-changing universe in which we live. As the study of Betelgeuse continues, astronomers are uncovering more details about its complex nature. The star's vast size and unstable behavior offer valuable insights into the life cycle of massive stars. The process of stellar evolution is both awe-inspiring and mysterious, and Betelgeuse provides an exceptional case study due to its proximity and peculiarities. One of the most intriguing aspects of Betelgeuse is the potential for its supernova to not only affect the local cosmic environment, but also to provide an unprecedented opportunity to observe such an event in real time. With modern tools like the James Webb Space Telescope, scientists can now look at the star's surface, its actions, and environmental dust clouds, allowing them to refine their models of stellar death. Such observations are essential in understanding the immense forces at play as a star like Betelgeuse transitions from a red supergiant to the explosive phase of its life cycle. The eventual explosion will create a shockwave that will travel through space, influencing nearby regions. This process enriches the interstellar medium, seeding it with essential elements that play a role in the formation of new stars and planetary systems. Ultimately, the death of Betelgeuse will contribute to the ongoing evolution of the universe, underscoring the interconnectedness of cosmic phenomena across vast distances. As astronomers persist in their observations, Betelgeuse remains both a mystery and a beacon of knowledge. Each fluctuation in its brightness, every unexpected shift in temperature or spectral signature, provides another puzzle piece in understanding the life and death of massive stars. These detailed studies not only inform us about Betelgeuse itself but also about the broader population of red supergiants scattered throughout the universe. Furthermore, the ability to anticipate and monitor a supernova in real time would be a monumental achievement in modern astrophysics. It would allow scientists to capture data at the exact moment of the explosion, observing shockwave formation, neutrino bursts, and gamma-ray emissions as they happen. Such data would be invaluable in validating theoretical models that have, until now, relied heavily on simulations and post-supernova remnants. The educational value of Betelgeuse's eventual supernova cannot be overstated. A visible supernova from a star so close, just about 700 light-years from Earth, would captivate not only scientists but the general public as well. It would serve as a rare cosmic spectacle visible to the naked eye, potentially even during daylight. This celestial event would inspire future generations of astronomers, physicists, and dreamers, reinforcing humanity's curiosity and drive to explore the universe. In preparation, observatories around the globe, including those in orbit, are continuously calibrating their instruments, refining detection protocols, and sharing data across international networks. This collaborative effort underscores the global significance of such a phenomenon. The anticipated explosion of Betelgeuse has, in essence, become a unifying scientific mission, a race not against time, but with it. While the precise moment of Betelgeuse's transformation remains uncertain, ranging from tomorrow to thousands of years from now, the certainty of its eventual death is indisputable. And when that moment arrives, it will not only mark the end of one star's journey but will also illuminate the dynamic, ever-evolving nature of our cosmos. In the meantime, Betelgeuse continues to shine, a quiet giant on the brink of transformation, reminding us all of the extraordinary processes that govern the life and death of stars. Its fate is a powerful testament to the cycles that define our universe: creation, evolution, collapse, and rebirth. And in studying Betelgeuse, we deepen not only our understanding of astrophysics but also our place in the vast tapestry of the cosmos.